In the previous videos, we have defined s as the distance, u as the initial speed, v as the final speed, and t as time. Here, we intend to introduce a fifth variable, a, as the acceleration. The acceleration equals the change in speed per unit of time. Let's take a look at this speed-time graph. We can see here that the speed is increasing. At the bottom we have a chart. Time is above speed. At time t equals 0, the speed equals 10. At time t equals 10, the speed equals 50. So, the acceleration equals the gradient of the line in a speed-time graph. With those of you familiar with Cartesian coordinates, you may know that the gradient of a line equals m. We have a linear equation. So in other words, we have to find the value of m in an equation in the form y equals mx plus c. How do we do this? Okay, so what we need to do is we need to get this measurement, 40. How have we come up with this measurement, 40? We have taken 50 and we take away 10 from the 50. In other words, we have got the final speed and subtracted from it the initial speed. 50 minus 10 equals 40. It looks like the height of a right-angled triangle. Here we would have the length of that right-angled triangle. How have we got 10? Well, 10 simply equals the time, the total time t. Now what do we do? Well, what we do now is we divide the height of the triangle by the length. In other words, a equals 40 divided by 10. A equals 4. For what? Well, a equals 4 meters per second squared. We have the acceleration. We can see this in a formula. A equals open bracket v minus u close bracket all divided by t. What happens if we multiply both sides of this equation by t? We get at equals v minus u. Then we can take it one step further. We can add u to both sides. Giving us the final equation v equals u plus at. This gives us the second SUVAT formula, v equals u plus at. Let's take a look at an example. Imagine u equals 10. Imagine we don't know the value of v. Imagine a equals 4 and t equals 1. Let's try and find the value of v. Well, v equals u plus at. So v equals 10 plus 4 times 1. v equals 10 plus 4. v equals 14 meters per second. We have a chart of this at the bottom. So at time 0, the speed equals 10. 10 being the initial velocity. At time 1, v equals 14. 14 being the final velocity. We can plot this on a graph. Every second, the speed goes up 4 meters per second. Okay, because you can see in this graph that the value of t equals 1. And the value of the speed has gone up 4 meters per second. Thus, a equals 4. So the value of a is indicating the change in speed. If it's measured in meters per second squared, it's indicating the change in speed in 1 second. Let's see if we can complete this chart. We have times 0, 1, 2, and 3. We have speeds 10 and 14. But what about 2? Well, the acceleration is constant, it doesn't change, and every second it gains 4 meters per second. So we just need to add 4 to the last number, to 14. So at t equals 2, the speed will be 18. Following the same rule, at t equals 3, the speed will be 22. It's important to note that the acceleration can adopt negative values. We call this deceleration. So deceleration equals a negative acceleration. This happens when u has a higher value than v. So we really can't have a negative time or negative distance or even negative speed, but we can have negative acceleration. We now have two SUVAT formulas. The first one that we had seen in the previous video, S equals 0.5t open bracket u plus v close bracket. This gives us the distance, the time, the initial speed and the final speed, and the new one, v equals u plus at. Here we have the variables of initial speed, final speed, acceleration, and time. Let's take a look at an example. A race car starts from rest and accelerates at a constant rate to 50 meters per second in 5 seconds. Work out the acceleration. Well, using this formula, v equals u plus at, we know that u equals 0 because it starts from rest. V equals 50. A we don't know, and t equals 10. So we substitute the values into this equation. 50 equals 0 plus 5a, thus 5a equals 50, thus a equals 10 meters per second squared. Let us take a look at another example. U equals 20, v equals 60, a equals 8. But what's the value of t? We substitute into this equation. So 60 equals 20 plus 8t. 8t equals 40. T equals 5 seconds. Here are some exercises. Sometimes I don't give you the value of u. Sometimes I don't give you the value of v. Sometimes I don't give you the value of a. And other times I don't give you the value of t. You will notice that sometimes the acceleration has a negative value. Please pause the video and try these